Hi guys, welcome back to Nerd Talk. I am really excited to have you here, so sit back, relax, and get ready for our 17th journey together. In this video, we journey through one of the greatest technological revolutions in human history, the birth of modern computing. From the gigantic electronic machine ENIAC and the first computer programmers, to the invention of transistors, programming languages, integrated circuits, and microprocessors, we explore how computers evolved from massive wartime machines into the foundations of personal technology. Discover the rise of Silicon Valley, the role of computers in space exploration, and the early beginnings of the personal computer era that would eventually change human civilization forever. The giant electronic brain. The year was 1945. Inside a massive wartime research facility, engineers and scientists stood before a machine so enormous it seemed almost unreal. Towering rows of electronic panels stretched across the room, covered in glowing vacuum tubes, switches, wires, and tangled cables. The machine was called ENIAC, the Electronic Numerical Integrator and Computer, and it represented one of the most important technological breakthroughs in human history. Before ENIAC existed, solving advanced mathematical problems required large teams of human mathematicians working manually for days or even weeks. But ENIAC changed everything almost overnight. When activated, the machine processed calculations at speeds humanity had never witnessed before. Problems that once consumed weeks could now be solved in seconds. Newspapers soon began calling ENIAC the electronic brain. To the public, the machine appeared almost magical, a device capable of thinking faster than any human mind. Although primitive compared to modern computers, ENIAC proved something revolutionary. Machines could process information electronically at incredible speed. Inside that glowing room, the digital age had quietly begun. The first programmers. Unlike modern computers, ENIAC had no keyboard, operating system, or software interface. Every new problem required the machine to be physically rewired by hand. Thick electrical cables had to be connected across giant panels, while switches and controls were adjusted manually. Programming was not typing code. It was almost like rebuilding the computer itself every time a new calculation was needed. At the center of this incredibly difficult work stood a remarkable group of women: Kay McNulty, Betty Jennings, Betty Snyder, Marilyn Westcoff, Fran Billis, and Ruth Lichterman. They studied complex wiring diagrams, understood electronic timing systems, and transformed mathematical instructions into physical machine configurations. In many ways, they became the world's first computer programmers. Programming ENIAC required extraordinary patience and precision. A single wiring mistake could cause hours of work to fail completely. For decades, the contributions of these pioneering women remained overlooked in computing history. Today, they are finally recognized as some of the founders of modern programming and software engineering, pioneers who helped humanity learn how to communicate with machines. The limits of vacuum tubes. Despite their revolutionary power, early computers carried a major weakness at their core: vacuum tubes. These fragile glass electronic components acted as switches controlling electrical signals, but they were large, inefficient, and extremely delicate. Thousands of them operated simultaneously inside machines like ENIAC, glowing intensely as electricity rushed through the system. The heat generated by these giant machines became a constant problem. Entire rooms required cooling systems just to prevent overheating. Engineers monitored the computers continuously because vacuum tubes burned out frequently, forcing technicians to replace damaged components almost every day just to keep the systems running. As computers became larger and more powerful, the limitations of vacuum tubes became impossible to ignore. Scientists understood that if computing technology was ever going to become practical for the future, something smaller, faster, and more reliable would need to replace them. The search for that solution would soon lead to one of the greatest inventions in technological history, the transistor. Bell Labs invents the transistor. In 1947, inside the research laboratories of Bell Labs, scientists John Bardeen, Walter Brayton, and William Shockley achieved a breakthrough that would permanently change the modern world. After years of experimentation with semiconductor materials, they created a tiny electronic device known as the transistor. At first glance, the transistor looked insignificant compared to giant wartime computers. But hidden within this tiny component was the ability to replace bulky vacuum tubes entirely. The transistor could amplify and control electrical signals while using far less energy and producing dramatically less heat. Few people fully understood the importance of the invention at the time, yet the transistor quietly became the foundation of modern electronics. Nearly every device defining the modern world, computers, radios, televisions, smartphones, and satellites, traces its origins back to that breakthrough at Bell Labs. The transistor revolution. Throughout the 1950s, transistors rapidly began replacing vacuum tubes inside electronic systems around the world. Engineers immediately recognized the advantages. Computers became smaller, faster, more energy efficient, and far more reliable than the massive machines of the previous decade. Entire rooms once required for giant computers could now be reduced dramatically in size. Heat generation decreased, maintenance became easier, and systems could operate for much longer without constant failures. The age of second-generation computers had officially begun. The transistor revolution changed more than machines. It transformed human imagination itself. Engineers now envisioned a future where computers might eventually fit inside offices, classrooms, and perhaps even homes. The foundations of the modern digital world were being built transistor by transistor. The rise of programming languages. Early computers could only understand machine code, endless sequences of zeros and ones written specifically for each machine. Programming in binary was exhausting, difficult, and extremely easy to miscalculate. Even simple operations required long chains of numerical instructions. Programmers spent hours translating mathematical problems into precise electronic commands. A tiny mistake could cause entire programs to fail completely. Working with computers during this era demanded extraordinary patience and technical skill. To make computing more practical, engineers began developing high-level programming languages. Instead of writing raw machine instructions, humans could now communicate with computers using words, formulas, and logical expressions. This breakthrough opened the door to the software-driven future. Software becomes human-readable. As programming languages evolved, computers became dramatically easier to use. Languages such as Fortran, COBOL, and Lisp allowed scientists, businesses, and researchers to solve increasingly complex problems through software rather than direct machine code. One of the most influential pioneers of this era was Grace Hopper. She believed computers should adapt to human language rather than forcing humans to think like machines. Her ideas challenged traditional assumptions about computing and helped redefine software development forever. Grace Hopper's work laid the foundations for modern compilers and programming systems capable of translating human-readable instructions into machine code automatically. For the first time, software itself was becoming more important than hardware. The integrated circuit. Although transistors made computers smaller than before, engineers soon faced another challenge. Advanced systems required thousands of separate transistors connected together through enormous networks of wires. As computers became more powerful, building and maintaining these circuits grew increasingly difficult. During the late 1950s, engineers solved this problem through a revolutionary invention called the integrated circuit. Multiple transistors could now be placed onto a single semiconductor chip, allowing entire electronic systems to exist inside tiny pieces of silicon.
Integrated circuits dramatically reduced computer size while increasing speed, reliability, and manufacturing efficiency. This breakthrough became one of the key foundations of modern electronics, enabling everything from calculators and spacecraft to smartphones and modern computers. Computers spread across society. By the 1960s, computers were no longer limited to secret wartime laboratories. Universities, governments, scientific institutions, and major corporations increasingly adopted computer systems to process information on unprecedented scales. Large mainframe computers handled payroll records, engineering calculations, census data, financial operations, and scientific simulations that would have been nearly impossible to manage manually. Entire industries slowly began depending on digital information processing. Although computers remained enormous and expensive, society increasingly recognized their importance. The world was quietly entering a new age, where information, automation, and digital systems would shape governments, industries, and eventually everyday life itself. The birth of microprocessors. By the late 1960s and early 1970s, engineers faced a new challenge. Computers were becoming smaller thanks to transistors and integrated circuits, but processors still required multiple separate components working together across large circuit boards. Then came a revolutionary breakthrough, the microprocessor. Engineers succeeded in placing an entire central processing unit onto a single silicon chip. What once required massive electronic systems could now exist inside something small enough to fit in the palm of a hand. The idea seemed almost unbelievable. A tiny chip carrying the computational power of earlier room-sized machines marked one of the greatest turning points in technological history. Microprocessors dramatically changed the future of computing. They reduced cost, size, and power consumption, while making computers far more practical for smaller organizations and eventually ordinary households. Technology companies immediately recognized the enormous potential of these chips. Engineers realized computers no longer needed to remain giant industrial machines locked inside research facilities. Computing power could now become personal. Inside laboratories and startup workshops, a new generation of innovators began imagining machines designed for individual people rather than governments and corporations. The invention of the microprocessor quietly became the foundation of modern civilization. Nearly every digital device today, smartphones, laptops, vehicles, satellites, medical equipment, and gaming systems, traces its origins back to those early semiconductor breakthroughs. Humanity had discovered a way to compress enormous computational power into tiny silicon chips. The age of personal computing was now approaching rapidly. Silicon Valley emerges. As semiconductor technology advanced, a region in California began transforming into the center of the global technology revolution. What had once been quiet agricultural land slowly evolved into a growing network of electronics companies, research laboratories, and ambitious startups. This region became known as Silicon Valley, named after the silicon material used to manufacture computer chips. Engineers, programmers, and entrepreneurs gathered there with dreams of reshaping the future through technology. A culture of rapid innovation and experimentation began spreading across the valley. Young innovators worked inside small offices and garages filled with circuit boards, soldering tools, and experimental computer systems. Unlike traditional corporations, many of these startups operated with bold ideas and unconventional thinking. The atmosphere felt electric. Every breakthrough in semiconductors or computing hinted at enormous possibilities for the future. Silicon Valley was becoming the birthplace of the modern digital economy. Over time, Silicon Valley would produce some of the most influential companies in technological history. The region became synonymous with innovation itself, shaping computers, software, the internet, smartphones, and artificial intelligence. What started as a concentration of semiconductor businesses eventually transformed into the nerve center of the global technology industry. Computers reach space. As computers became more reliable and compact, they began playing a critical role in one of humanity's greatest ambitions, space exploration. During the space race, advanced computer systems helped calculate trajectories, navigation systems, and spacecraft operations with extraordinary precision. Without computers, missions to the moon and beyond would have been nearly impossible. Inside mission control rooms, engineers monitored streams of digital information flowing from spacecraft, traveling far beyond Earth's atmosphere. One of the most remarkable systems of the era was the Apollo guidance computer, used during the Apollo missions. Compared to modern devices, it was incredibly limited in power, yet it successfully helped astronauts navigate through space and land on the moon. These computers represented a new relationship between humans and machines. Technology was no longer simply assisting calculations on Earth, it was helping humanity explore entirely new worlds. The success of space computing accelerated advancements in electronics, software, and miniaturization. Technologies developed for space missions eventually influenced consumer electronics and modern computing systems used around the world. Computers had expanded from wartime laboratories to the edge of space itself. The dawn before the PC era. By the early 1970s, computers had undergone an extraordinary transformation. Machines that once filled giant rooms had become smaller, faster, and increasingly reliable thanks to transistors, integrated circuits, and microprocessors. Yet for most ordinary people, computers still remained distant and inaccessible. They were expensive systems, mainly owned by corporations, governments, and universities. Very few imagined that within only a few years, computers would begin entering homes around the world. Across electronics clubs and technology communities, hobbyists and young programmers experimented with computer kits and microprocessor systems. These early enthusiasts believed computing should belong to individuals, not only large institutions. Inside garages and workshops, a quiet revolution was beginning. People were preparing to transform computers from industrial tools into personal machines used in everyday life. The foundations of the personal computer era were almost complete. Humanity stood at the edge of a completely new technological age. The next chapter would bring personal computers, software companies, digital communication, and eventually the internet itself. The computer was about to leave the laboratory forever and enter human society on a global scale. The dawn of personal computing. By the mid-1970s, the world of computing was beginning to change dramatically. Advances in microprocessors made computers smaller and cheaper than ever before, opening possibilities that previously seemed impossible. For decades, computers had belonged almost entirely to governments, universities, and giant corporations. But now, a growing number of engineers and hobbyists believed ordinary people might someday own computers themselves. Inside garages, electronics clubs, and small workshops, a quiet technological revolution was beginning to take shape. Young enthusiasts gathered around homemade computer kits filled with wires, switches, and microprocessor boards. They spent nights soldering components together, experimenting with software, and imagining what the future of personal technology could become. To many outsiders, the movement seemed strange and unrealistic. Few people believed computers would ever matter to everyday households. Yet within these small communities, excitement about the future of computing continued growing rapidly. The idea of personal computing was slowly becoming real. For the first time in history, computers were beginning to move beyond giant institutions and into the hands of individuals. The shift represented something far larger than technology alone. It marked the beginning of a new relationship between humans and machines. The personal computer era was about to reshape education, communication, entertainment, and modern society itself. Thanks a lot for watching. If you're liking the videos, please do like, share, and subscribe.